Hello and welcome. You're listening to Marketing Matters on the Wharton Podcast Network, our weekly podcast where we analyze the latest in advertising, marketing, customer behavior, new product launches, retailing, and pharmaceuticals. I'm Barbara Kahn, the Patty and J.H. Baker Professor of Marketing, and I'm joined by my co-host, Americus Reed, the Whitney M. Young Jr. Professor of Marketing, and the brand identity theorist. Hello, Americus.
Hi, Barbara. So this is the first week of classes. It's an incredible sort of energy on the campus. I'm loving it. One of the things we talked about today is level
Can I
setting.
just mention it's your
Sure.
first week of classes? I've been teaching for like 7 weeks.
7 weeks in. So you're like, listen, I'm into it now. Americus, you're bright-eyed and bushy-tailed, but hey, it's going to catch up
We're
with you.
all on midterms. I don't know where you are.
I'm introducing the syllabus. And so, yeah, no, it's fascinating that you mentioned that because, all of the things that are going on campus, one of the things I talked about today, Barbara, is we're talking about marketing and people think marketing is just advertising, but I was trying to explain to my class, marketing is about strategy. And in fact, marketing actually starts with science and ends with art. And so I'm very fascinated by this interface of data science, artificial intelligence as a new technology that is making its way into marketing strategy, various ways that it's happening, and all of these different interfaces. And so, have you got anything for me today that can help illuminate this and further allow me to make the case to my students that there's a lot going on under the hood with respect to marketing strategy?
Well, actually, we have a very interesting guest today who can talk about a lot of those things because he's had a long and varied career. I'd like to introduce Sean Bruich, who's currently the Senior Vice President of Artificial Intelligence and Data at Amgen, which is a pharmaceutical or a biotech or anyway, health kind of related company. But he has a long history, starting out at Stanford as a psychology and biological science major, all the way through Google and Facebook and Nike. So he's kind of been at the right place at the right time. Anyway,
Nice.
welcome, Sean,
Welcome,
to our
Sean.
show.
Thank you, Americus. Thank you, Barbara. It's so great to be here.
So let's build on Americus's quest or introduction in some sense or question, and just quickly go through your background because you do have a knack of being in the right place at the right time. Starting, well, Stanford wasn't the right place. You should have been at Wharton, but okay. You started
Had
at
to get that
Stanford.
plug
We'll
in.
give you
Very, very
that.
well done, Barbara.
But then
Yeah.
I think you went first to Google, then to Facebook, then to Nike, and now to Amgen. Just as each one of those areas was doing some pretty interesting area connecting marketing with data science. And now what I really like to talk about is what you're doing at Amgen. But let's start with your history.
Sure. Yeah, I got my start up at Stanford, and I was working in a neuroimaging lab. So this was right around the time, these new brain scanners were being able to gaze into the working human mind, functional magnetic resonance imaging. And there were kind of two things that happened there. I think the first was, this new technology allowed us to, for the first time, answer some questions that for 70 years in cognitive science weren't really answerable. And so I became really convinced. Up until that point, I'd been, studying science, but I became convinced that technology was going to be really important in understanding the world. And then the second thing was I had to learn how to code because these data sets were so much bigger than the reaction time and wet lab and survey data that sort of everybody was using at the time. And so that's what really got me started in my career. And I got a job at Google right at the beginnings of what you would now call consumer data science. Had just a wonderful set of mentors there as we were sort of exploring what was possible with this field. I went to Facebook and helped them launch the ads business, where I led the measurement science team, the data science team on the ads business. And then I spent the last 10 years at Nike, where I helped them with their direct-to-consumer digital transformation, leading their data science and analytics and customer insights teams there. But as you said, I made a big switch about a year ago. So now I'm at Amgen, which, if folks don't know, is one of the world's leading biotechnology companies. It makes medicines for things like cancer and inflammatory disease and cardiovascular disease and rare disease. It's been around for over 40 years. It was sort of one of the pioneering companies in the biotech revolution of the 1980s. And my job here is to try to figure out how we can use AI and data to make better medicines for patients.
So let me just build a little on this. Now you've been there a year, and um, I mean, I know you were what that health, what did you say, biohealth or biological science undergrad major, but that's not like major health credentials. So, but obviously they saw some advantage in what you did do for the last 10, 20 years. But how have you like learned about what Amgen does, and how did you get up to speed? How did you do that?
Yeah, and it's been a long time since I took my last biology class at Stanford. So, yeah, and I mean the science here is really complex. It's genetics, it's biology, it's pharmacology, and so it has been definitely a big ramp to learn all about what we do at Amgen. And it is pretty different than online ads or shoes in a few ways. I mean, I think the first is just the fact we're making medicines for patients, which creates this incredibly high standard around reliability and safety and compliance and scientific accuracy. Um, but it is a scientific discovery, especially in this space, where you're trying to take this molecule and turn it into a medicine. It uses really large data sets. It's actually surprisingly quantitative for me. I mean, there's definitely beakers and labs and experiments, but it's also very quantitative. Um, and it's increasingly relying on technology because the data sets are huge and these, new artificial intelligence and machine learning algorithms, we think, has the potential to really change sort of how we bring these medicines to patients. So some of it is definitely new and hard and a ramp, but some of it feels, much more comfortable. The core first principles of data science or the underlying technology stack and the partners and things like that.
So if everybody is using AI, then how do you differentiate? I mean, it seems like if you have AI, everybody's doing the same thing then. How does that work?
Yeah, you bring up a great point, Barbara, and I do think there's a lot of convergence now on how well these algorithms perform. So in the old days, when I was getting my start as a data scientist, your magic sauce was very much like how good your algorithm was, how good your model was. Um, Nowadays, I think companies should be thinking about two things, and certainly we are here at Amgen. But I think if you look across, my work previously, it was the same concepts. The first is the underlying data that you have as a company is a pretty interesting differentiator, and I'm super excited about some of the data we have here at Amgen. Genetics data, a long history of designing proteins and molecules and all those scientific experiments along the way. There's that set of data is a really interesting differentiator.
Mm.
And then I think increasingly what you're seeing is that there is an art and a science. Americus, you mentioned kind of the art and the science of how do you implement these algorithms in a way that is impactful, in a way that gets to scale quickly,
Mm.
and then realizes whatever impact you're trying to drive at your company. And I think in both spots, there's going to be differences in how successful companies are. And so I think that's kind of one of the most important and underappreciated parts of how to win here.
I love that point, Sean. And one of the things that I talked to my class, Sean, is the idea of adoption of AI technologies. And the statement that you made, which is how do you make the company strategy infused deeply with the DNA of AI? That seems not necessarily easy because you have different folks, maybe even if it's a large company. And, aside from just having a bunch of young people who are sort of born into it in your company, how do you go about creating the right organizational culture and atmosphere where the adoption of these technologies and the understanding of how to use and deploy them appropriately and well differentiated, like Barbara said, how do you make that happen? What are the What are the things that you do to create the cohesiveness inside the building to be able to adopt that kind of culture?
Yeah, I mean, this is a podcast, right? So we have to have some controversy. Can I bring up the MIT AI paper? Because
Yes.
it's definitely a controversial topic, and I think
Yes.
one that's worth digging into a little bit because I think it strikes right at the heart of kind of your question. Okay, so for if people are not tracking, there was a paper by MIT that came out probably 4 weeks ago that the headlines have all said 95% of AI pilots in companies don't generate value. Now that's the headline. The real story, I think, is twofold. So the first story is that if you're in a big company and you do a pilot, it never generates scale business value. That's the whole point of a pilot, right? Is it's little. Now there's a muscle around how do you choose the right pilots because pilots are only valuable if they teach you something you didn't know or de-risk an investment by trying it out in a specific zone or sometimes I think what as you mentioned shines a light on a success story that can absolutely inspire and teach your colleagues and your workforce a path forward. But lots of pilots, lots of sort of poorly thought through, poorly targeted, random pilots is not a good measure of success. And there's a lot of
Interesting.
companies, I think, doing way too many pilots that are kind of not ever going to generate real value. Because then you have to have the practice and the skill set and the technology stack and the monitoring capabilities to take the winners and get them scaled and adopted. And that I think is a real lesson from this paper. Now, why did these 95% of these programs in this paper fail? It says always in the headline, it wasn't the AI technology. It wasn't like the algorithms were crappy. It wasn't that the AI failed. It was everything else about it. There wasn't alignment on the budget. Business processes weren't evolved. There wasn't receptivity on the part of the people using it. They didn't get adoption.
Oh,
And so that speaks exactly to your point, which is even if you have an amazing capability, if you don't get everybody else lined up around it in a big company, you're never going to get the business value out of it. And I think that's another piece that companies are struggling with is how do you line up everything such that you can really pull these through to value and make an impact on on whatever mission you're trying to accomplish.
Well, so how do you do it?
I think it's this. There's three pieces. I think you have to have the discipline around where are you going to do the pilots and what are they designed to teach you. And here at Amgen, we have a very rigorous process. It's not anybody can run any pilot anywhere around AI. We're directing those pilots at specific zones that are going to teach us something. You have to have this muscle around how do you take a great pilot and get it to scale. So that's a technical question around, do you have the right data infrastructure? Do you have the right um, technology portfolio? Do you have the right monitoring programs to get these algorithms implemented? And then there's all of the change management stuff that, is not all that different than every other technology transformation that you guys have studied, that we've looked at digital marketing, 15 years ago, direct to consumer, 10 years ago. Um, but if you don't have all three of those, I think it's really hard to make a big impact. And one or two of them isn't enough.
So let me just summarize that. So like the first one is kind of how to ask the right questions, right? Where to focus is the first thing. And you can ask a lot of wrong questions, but understanding where you're focusing is basically what you're saying. And I could totally see how that'll differ from firm to firm to firm. So it
mhm.
wouldn't result in the same thing. And then once you get viable ideas, implementing and bringing to, and operationalizing and then scaling is a whole other issue. And then the third one is getting the organization around this new. Is that it?
Yeah, I think that's a great summary. It's the discipline around pilots, where you play, how you test ideas, how you turn the one yeah, turn the big ones, the best into impactful scale programs. And then how do you line up all of the pieces that are necessary to make the impact through those scale pilots for sure.
So it seems like how to do it right would suggest that there's like some measurement system or some objectives and some like
Mm.
metrics that you have along the way in order to see if you're making progress. Is that kind of the way it goes, or how do you know you're on the right track?
Yeah, look, I think there are, you know, a whole host of technical things we do to make sure these models are performing well, and having thoughtful evaluation frameworks, and looking at their performance, and all of that stuff is sort of the job of the data science team or the AI team. But I think the bigger question goes back to that conversation we were just having around, is it actually making an impact on your strategy? Is it driving whatever outcomes you as a business are you trying to enact? And that, I think, is the place where sometimes, the plot gets a little bit lost. You focus too much on the technical implementations or the technology roadmap, or the path that all the data and algorithms and the technology stack need to be all right. And sometimes you lose track of the organizational and business partnership.
When we understand what you're saying, Sean, which is like the specific role of the technology needs to be managed in a way that is built around the synchronization of its adoption within the organization, and how to, in your case, how to figure out the specific biology that produces new opportunities for wellness products or health related protocols and things of that nature. So we definitely understand that. It's just challenging because whenever I hear a talk, Sean, on AI, and you're a guru of this, I sit back and I have to like suspend a lot of my judgment because I just don't know what you're talking about in terms of the technical pieces of it. All of these sort of things. I understand the logic of it, but I want to know much more, to Barbara's point, about how does this work? What's an example of a specific pilot, if you could share that? Things that you guys have done. Maybe that's the secret sauce and you can't talk about it, but like taking us through, like, here's something we did that's more public information now, and here's an example of how we really brought in AI to really help us drive a specific understanding of a biological element that then turned into something that we could quickly scale and create something that adds value to the marketplace. Is there an example you could share with us?
Sure. Yeah. I mean, I think what is exciting, and part of why I wanted to come to Amgen is I really do think biotechnology is a spot where um, some of the biggest advances in AI and data science are going to happen over the course of the next few years. I mean, I am so excited about what's possible, and there's been some big breakthroughs. And just last October, the winner of the Nobel Prize in Chemistry was shared between the Google DeepMind guys, Dennis, and a professor at the University of Washington, David Baker. And with that breakthrough was an algorithm called AlphaFold, which was solving this like incredibly complicated problem in science, which is how do you predict the way proteins fold? If you know
Oh,
the two-dimensional sort of structure of the protein, can you predict the three-dimensional structure? And that,
interesting.
fortunately, that actually happened after I joined Amgen because it
Okay.
attracted a whole bunch of news to the fact that AI and data science had potentially a big impact on this field. But since I had joined a few months earlier, it looked like I was super smart and my timing was perfect as opposed to joining after the news coverage. But that's an example, I think, of a big breakthrough. And there are relatively few of those along the way.
Mm,
I think the more common instantiation of like an incredible impact of a data science project is actually just much more simple. So let me give you one.
okay.
I did not know any of this a year and a half ago, but it turns out to be a good medicine, the molecules have to be a certain very narrow range of viscosity.
Mm,
So like imagine
interesting.
you have a molecule, it works pretty well, but it's like peanut butter, like too thick. You
Yeah.
can't inject that into the human body. It's not going to work. And so
Got it.
one of the most important criteria our scientists have to consider when they're designing these
Got it.
molecules is like how viscous is the solution of these proteins after we engineer them. And even that, developing a machine learning algorithm
Ah,
takes into account all the historical experiments
got it.
and
I
makes
see.
a prediction as to whether these molecules are going to be in the right zone to be
Got
a
it.
medicine can dramatically improve the efficiency of our scientists.
Got
So,
it.
they don't have to make 100 of these molecules and then see how viscous they are. They can use this algorithm and it dramatically cuts down. It may not be right all the time, but
Hmm.
it at least improves the efficiency of those scientists, lets them direct their energy, their creativity, their time against a higher fidelity of candidate, right? A smaller
Interesting.
pool, more likely to be successful. So, those are the type of like blocking and tackling
Yeah.
incremental work
Yeah.
that, before we had access to all of that data being digitized and before our algorithms were powerful enough to make strong predictions, you couldn't reduce that workload. You couldn't shape where they're spending their time and attention. And
Interesting.
that's the type of stuff just across the board we're looking at. How do you, add a little bit of data science into the day of a protein engineer or a biologist or a geneticist or a process engineer, or a supply chain expert, right? And
Right.
just incrementally move the needle on how efficient and effective they can be.
So, Sean, one of the things I'm interested in as you're telling us the critical role that AI does play and how it can really make things better, one of the things people are really afraid of is AI replacing other, people working at a company. But the way you're describing it, it doesn't sound like that to me. And I wonder if you agree with it. It actually sounds like there's more room for people who know how to use AI and are trained to use AI. And it might even provide more jobs than less. I almost got that impression from what you're saying, but I don't know if you want to go so far as to say something like that.
Yeah, I'm no economist, so I won't weigh in on maybe the economics of it. But I'm thinking about it in two ways. I think as we're implementing AI systems today, that human AI interface is actually critically important. And so, we call it human in the loop. That's kind of the term folks are using. But particularly when it pertains to like scientific inquiry and ensuring quality and compliance and adhering to like, the incredibly high standards of scientific accuracy that we have to adhere to, having a human inside that system engaging with the technology and the AI algorithms themselves and the output is critically important. And I don't see that changing anytime soon. The other thing is as we build these systems, there's a whole set of new roles that are being created
Yeah, that's what
that
it sounded
exist
like.
on this edge. I mean, look, just to zoom in on my career, I have never had a job in which there had been a prior incumbent in that job over the last 25 years.
That says
Now,
something about you, but
Yeah. Yeah.
I don't want to overextend from an N of one, Barbara, but I think everyone would agree that's dangerous in science and marketing.
yeah.
But but I do think it speaks to this is an exciting time. I mean, when I look at my whole career and I've been around data science since the really early days, this is the single most interesting, exciting moment that I've seen in that time. I think the capabilities, the combination of computing power and data that's been digitized and available, and the performance of these new models is really transformational. I think tools like ChatGPT are just incredible. I'm sure many of your listeners are big users of it.
Yeah, I'm sure they
Um,
use it all the time. yeah.
Hmm.
and then, I really do think one of the biggest challenges in data science over the last 20, 25 years has been just it's been really restricted to people who are really high skill. Like, we know Python, know how to use the technology, work at a company that has big data sets. But the other thing that's really fun here is this has really democratized the power of data and algorithms in a way
Interesting.
that almost everybody out there listening can probably find, a handful of spots, even just in their own lives, whether it's making shopping lists or planning vacations or automating workflows, getting work done faster, that's going to have a pretty big impact. So I'm really excited about the positive impacts that these new technologies are going to have on us at work and us outside of work.
Yeah, Sean, this is super intriguing to me. I want to, ask this question because I think it's important when we have the gurus available to us to put them into the time machine and give us some insight into their crystal ball about what is the state of the world in your domain, artificial intelligence, data science, all of these things. What is that going to look like in your view 5 to 10 years from now?
Well, I am too good of a data scientist to get busted by making predictions too far into the future. So I'm gonna tell you what I think now, and then maybe gaze just a little bit more
Touche.
proximately into the future. But look, I think the biggest mistake people make in a moment like this around a big technological revolution, and evolution of data science and algorithms and data is that they over focus on the here and now, the failures of technologies, the hype cycles that turn out to be, overheated, and they underestimate in the medium term how pervasive and impactful some of these technologies can be. And I think that's the big disconnect I see right now between kind of the here and now. We've all had a moment where the algorithm didn't do what we wanted it to do, or there's not enough data to make the prediction, or ChatGPT gives you a lousy answer, and those things are true. But I do think in the medium term, folks are underestimating
Mm.
how big of an impact this new set of capabilities is going to have, and that's a big part of why I came to Amgen. Is I'm really bullish on what I think is possible here. Now, you got to do all the stuff we talked about to actually make the impact at scale. But I think this is a really exciting space to watch, and folks should lean in and watch it.
Well, Sean, thank you so much for joining us today. It's always a pleasure to have you. And where can our listeners go to keep up with what you're doing? Do you have a website or public facing side of Amgen so people can figure out, how Amgen is leaning into AI?
Yeah, definitely. If you're interested in either the science or the AI of what we've talked about today, check out amgen.com. There's a bunch of great stories, and the teams there keep everybody up to date on what we're working on.
Okay, well, that's great. Thank you very much. And that's all we have time for today. We'd like to thank our producers, Aaron Tran and Marissa Renna. And thank you all for listening. We'll be back next week. Till then, this has been Marketing Matters on the Wharton Podcast Network. I'm Barbara Kahn here with Americus Reed.